This is Mech 330 Programming for Industry 4.0. We're first going to show how the code kind of runs for this week. We're going to start by putting in some values for the sequence. So what order should the lights appear? And then I have an example here of ways that it could be inputted. I'm asked how long you would like the LEDs. So I can put in either just a value here as 3 or a float. I'm going to do a float. And then it tells me my sequence and my duration. And then I'm asked if this is correct or not. If I say yes, I will then save this onto a file, a text file, or write it onto a text file to be more correct. If I say no, I'm re-looped through, and I'm able to give another option. So we'll do 3, 2, 1, 4, and then I'll change the float value. And if I say yes, then my sequence is successfully saved to sequence.txt. So then we open up sequence.txt inside my Python work file. We can see that value is now here. We then take this file and we bring it to Muse files. And we're going to drop in sequences.txt. And then when we run the code, I'll show you what the output looks like. Now, if we look at this text document, the third LED, the second LED, the first LED, and then the fourth LED should be lit in that order. And then there should be a 4.5 second pause after each, and then the color should be blue. So we're going to run the code. That's the third light. That's the second light. That's the first light. And that's the fourth light. And then the code's completed. So to take a look at the code that I wrote for this, I start with a while true, and then I take the input of the order of the lights and I put that to sequence, and I take the input of how long they should be on in seconds, and I put that to duration, and then I put a confirmation in here, yes or no, and then I make that confirm lower because if they put in uppercase, it just corrects that. And then if confirm is yes, we're going to break the loop and continue on to the code. If it's a elif confirm no, we're going to re-loop. And then if it's something else, so anything but yes or no, we're going to actually exit the program and give them a valid, like a reason why, invalid input, exiting program. We're then going to start processing our input. We start by making duration and storing it in duration float. And then we take our RGB for blue and we store it in blue color. And then we're going to split sequence by the comma and store it into sequence list. And then we're going to make an empty list called output string to build up output string. We then take the length of sequence list then counting from 0 to whatever the length is of sequence list. In this case, it was 4. And then we make that a range from 0 to the length of. And then we're taking all the elements from sequence list using index sequence count and appending it to output string. And then as we add each element of sequence list to output string, we're going to add a comma after each, unless it's the last value, using this if statement. And then here we're going to add a colon, after output string, and then add a colon after duration float. So that's just going to separate it so we can separate it later for splitting. We're then going to append blue color to output string. And then we're going to write a file called sequence.txt, which contains the string, output string. So that's how we get this file right here. Then we're going to look at the hardware side. So to take a little bit more of a look at the hardware side, we just do our normal imports, board, digital IO, time, and NeoPixel. Then we prepare our NeoPixels by doing board.neopixel and assigning it to NeoPixel pin, our number of NeoPixels that we're using for, and then we put these both into a variable called pixels. So then we're going to read the file sequences with open file name read as file object, and then we're going to use file object.readLines, which is going to put this all into a list. And this list is going to look like this. So for example, 1, 2, 3, 4, 4.0. If we look at our prior one, it'd be very similar, except 3, 2, 1, 4, 4.5, for example. And then we're left with this r/r/n new line. And that's just from bringing it over from the text file. So we're going to take the first element of lines, which is the first line, and we're going to strip that, and we're going to store that into single run data. And then we then split single run data by the colon that we added earlier. So that's the reason we added it, was so we could split it very quickly, very easily. And now our list can be separated into 3 different variables by indexing into split single run, as we can see. So split single run 0, split single 1, and split single run 2. And we actually are going to make this one a float immediately here, because nothing else has to be done to it. We can just turn it right into a float. And then we're just going to put reset color here as a off for the RGB values. We're then going to do something very similar to as we did on the software side. We're going to split sequence by the comma using the split method. And we're going to store that into split sequence. We're then going to iterate through split sequence and convert it into an integer, just like we did the last time with the len and the range. And then we're going to split blue color in the same way with the comma, doing the split method. And then we're going to iterate through split color and convert each string element also into an integer. And that's just so we can use it for this for loop. And then we're going to iterate through split sequence for LED. And what we're going to do is take the index that we get and -1, and that's going to be the index for the LED. And then our RGB value here is going to be a constant. And then we're going to have a float as our duration or our sleep value here. It's a variable sleep. And then we're going to have another constant reset color to turn off our light. And that's everything for this week. Thank you for watching.